Hi everyone, welcome to this video. In this video, we will be learning about the root detection bypass techniques. So we will be learning about objection, we will be learning about FRIDA and how we can bypass it. Okay, so let's start it. First of all, we will be using this DAM vulnerable application. So as you can see, this is the DAM vulnerable bank application over here, and this is the package name of that. Now, let's try to run it without any uh, tools used. Okay. So as we can see over here, here is the error that phone is rooted and FRIDA is running. Okay, so there are we can be able to say that there are two checks. One is for the root detection, and another one is for FRIDA detection. Right. So what is actually root detection? So applications what do is basically application checks that the device is rooted or not, because rooted devices basically anybody can use that device access to the kernel and the operating system access of you can say root privileges. So it is considered as a harmful, so many applications check this, and they don't allow to run the applications on the rooted device. So first of all, what we have to do is we have to identify that the code which is checking that application is rooted into the JADX. So we have already seen how to install JADX previously. So what we do is basically we will go and open JADX, and we will identify that uh, this is the JADX, and we will just you can say open the file, and here is the APK file. So we will just feed the APK to the JADX GUI. Now for the first thing is we need to identify the errors, right? So as we have seen over here, we have to just see the text of the error. So the first text will come is phone is rooted, right? So let's try to identify that into the JADX. Right. I will just write it down. Phone is rooted, and as you can see, we have one instance where the string is matched. Right, this is the string match. You can identify from over here. If you want to go there, click on that, and it will just show you that what you want to search. Here is the option of search for class. Okay, so it is for class, and this is for comment. So let's start with this. I will type it again. Phone is okay. So over here, as you can see, it popped out. Double clicking on that will take you to uh, the particular string which is identified, right, which is searched and identified, exact match. All right, so as we can see over here, it is under dashboard, and it is under package com app dam vulnerable bank. So we can also go from here, com app vulnerable bank, and we will go to the dashboard. And if you open the dashboard, it is the same uh, you can say the file, and these are the methods, like the Java methods. All right, now we have identified that this is the particular you can say code that is throwing the errors. Now what we have identified over here is, as we can see, this is uh, the real, you can say, the class and the methods over here, which is actually checking that whether this phone is rooted or not. So if it is like checking for the if the value of this is there, then we have to just throw an error that the phone is rooted. Okay. So let's try to identify what is there inside that. So over here it will be shown here, right? A dot A dot A dot A, and over here you can see the R method, M N O P Q R. So here is the boolean method R of that particular class. So it is actually not a proper decompilation, but we can definitely see that there are different binaries which are being checked over here, that whether those binaries are available into the device or not. And it is throwing a boolean value, so it is kind of an, if it is true, we can clearly see that this will be called, and if it is true, then it will just pass to that particular dashboard, you can say over here, and the message is through. All right, so we have identified that this method is responsible. Now we can directly go from here also. If you press the control and click on this R, it will just directly uh, you will directly come here, and you will see that the same method is selected. So you don't have to just go to this directory structure. All right, now once we have identified the code that this is the actual method which is sending a boolean value, right? So now let's fire the objection, and let's see how if we can be able to bypass this or not. All right, first of all, let's see that objection is available or not on the system. All right, objection is there. If it is if you don't see that, you can just directly pip install objection and it will install. And if you are using pip3, you can just keep it like this. Okay, now um, let's identify that which package is the package name we have to identify, right? So simply what we can do is just click over here, app info, and this com.app.dem vulnerable bank, the package is this. Okay, so let's fire the command objection hyphen gadget dot app dot explode. Okay, and we can see that without we haven't used any other bypass techniques over here. We just explode the application with just objection command, so it won't just bypass as it is. Okay, so what we can do over here is we can just objection explore hyphen h. Okay, hyphen. Okay, so there is a tag called startup command over here, which is basically tells us that the command to run before the REPL polls that device for the information. So what we can do over here is we can just add a command which will run at startup when the objection fires. So we have already identified the method which is responsible for this root detection in the application. So what we can do is we can just run the objection command, the default you can say root disabled settings from objection framework. So over here is objection hyphen gadget is basically this particular package name which we are trying to bypass the root detection. We are exploring, and hyphen s is responsible for the startup command. So whenever the objection framework runs, it will just run this command at the startup. Just we are using it over here just because it is the first check when the application gets started. So whenever we try to run it objection and run through that framework command line, it the method is already called, so it won't be able to bypass it directly. So what we will do is we will just run this startup command, and let's see how it goes. Okay, so we are using it, and it doesn't work. Okay, So the Frida check is there and root detection check is still there. So what we can do is now we will just exit from this objection framework. We will try to bypass it using Frida. Okay. So as we know that in the JADX we have identified that this is the Boolean method. The method isn't decompiled using JADX GUI, but we can be able to say that this is a Boolean method, and it is called over here, right? So if this is true, then it is just checking that the phone is rooted is should be popped up as a toast message. Okay. So what we can do is we just try to send negative value. Okay. So if it is Boolean, then we can just send it false using Frida. So what we will do for that, uh, we have a Frida script over here. Uh, this is just basically JavaScript. What we are doing is we are just defining the particular class, that this is the class. Okay, we are defining it as a bypass. We are overloading it, and we are just printing out that root detection. We are bypassing the root detection. So we will come to know whenever this console.log will be printed on the screen, we will come to know that this function is called, and we are overloading it and returning the value of false. So simple. We will just copy this command, paste it, and we will run it. So as simple as that, Frida-L is basically this JavaScript file -u, which suggests that we are running it on the USB devices connected, which is this phone. Okay. -f is just package name. -hyphen no pause, which means that it won't pause. So otherwise, if we are running Frida, it will just go to the Frida console and it will pause for some times, and we have to resume that Frida running. So simple command line. We are just running it, and once we run it, alright, so Frida is running. It means the root detection check is bypass, and it is just only checking for Frida. And as we know that the root detection bypasses, the method is called and it returned false over there. Okay, so we have successfully bypassed the root detection check over here using Frida. Alright, okay, so we have bypassed the root detection, but we still cannot be able to access the application, right? Because Frida check is there. So now let's try to bypass the Frida check and see whether our root detection check is working or not. The Frida script is. So what we can do is basically we will just identify the same way we identified the Frida, sorry, root detection checks. So we will just go to JADX GUI. We will try to find out this Frida. Okay. So because the pop-up, the error which is showing is Frida is running in that particular toast when you run the application. So we'll just try to see that whether the Frida check is there. Okay, so we can be able to find that a single check is there. So let's yeah, so when you just open this, it will show you something like this. Now I will just write it down, Frida, and I will find out these three uh, search results. So over here we can see that there is a public class Frida check JNI, and this is loading a library called Frida check. So basically it's a native library which is checking for the Frida. Okay, so we cannot be able to directly uh, monitor using you can say Frida right now, but what we have identified is that if you quick search in Google, you will check that this is the native library, which is basically checking few simple checks. So what they are checking is by default Frida run on 27042 port. Okay, so if you just load this particular, if you decompile the application and find out that SO file .so file for Frida check, fridacheck.so, and just load it into the Ghidra or any other you can say um, decompiler for assembly checks, right? So you will be able to identify that it is just checking about a particular port on Frida which is running. So what we will do right now is we will just kill our Frida, which is by default running on 27,042 port, and we will run it on a different port and see whether it works or not. So this is kind of a quick fix. uh, in most of the cases it will work. Okay, so there are multiple Frida scripts also available, but this is the easy one. So let's see how we can be able to bypass this. Okay, so first of all what I have to do is uh, go to the adb shell and kill the current Frida server process. Okay, so what I'm doing is basically just listing the processes and grabbing the Frida from that. So I can be able to identify that there is one process ID which is 3587, and which is running the Frida server. Okay, so what I will do is just kill 3587. Now we have killed the process. Okay, there are no processes available. Now to run Frida on a different, you can say, port, we have a particular command for that. Okay, so what we will do is just dot slash go to the location where Frida server is there, data local temp Frida server hyphen L argument. We are running on any port. So what we will do is we just run it on 1337. Okay. So this just tells us that we are running Frida server on a particular 1337 port. Okay. Once you do that, now what you have to do is basically uh, we have we were running the Frida commands, right, for root detection bypass. This one. Okay. So what we will do is just keep we will keep the same command, but we simply uh, change the IP. Okay. So this IP is this device IP. Okay. This is the remote IP, which is showing over here on 1337 port, which is we are running the Frida over here. Okay. We are giving this as a host. Okay. This hyphen H will suggest that it is a remote server. Hyphen L, similar command which we discussed earlier. Hyphen F, the package name, and hyphen F will no pause. So let's try to run this and see whether it works or not. So over here, okay. So as the toast were suggesting that the Frida is not running, so we successfully bypass the Frida check, and we have already bypassed this root detection. So we can be able to show that we can be able to bypass this root detection check also. Okay. Uh, Thank you for watching the video. Stay tuned for the next video.